In this video note, we should be looking at getting started with the tech support project from Objects First with Java. The project is based on ideas that can be found in the groundbreaking ELIZA program by Joseph Weizenbaum. We shall assume that you have already had a chance to interact with the full version of the program, which is to be found in the Tech Support Complete project. However, we shall not assume that you have already started looking at its source code. The version we have open is Tech Support 1. This version does very little. If we call the start method, we see a welcome message printed in the terminal window and an invitation to describe our problem. However, what we type just elicits an unhelpful response. The one thing that does seem to be recognised is by. However, even this has limitations. If there's any space in front of what we type, then it's not recognised, or if we happen to capitalise, that's not recognised either. On the other hand, if we were to type bye, that's actually recognised. So clearly the program needs some work. At this stage, it's probably worth making a point about the user interface of the program. We can see that the program's connection to the outside world, i.e. customers, is in the form of text. It reads each question as a line of text and outputs its answers as text. However, there's nothing actually stopping us from implementing a more sophisticated web-based interface if we really wanted to. But that wouldn't change the fact that the question and answer part of the program will have to know how to deal with text. The obvious class to use in Java for processing text is the string class. Up to now we've largely dealt with strings in the form of string literals, as we can see here in the responder class. We've also seen that we can concatenate strings to make new strings, often when printing output. In working on this project, we'll need to learn some more about the string class and what string objects can do. How can we find out more about strings? Well, the string class is part of the Java Application Programming Interface, or API. This is a library of classes that contains, among other things, the ArrayList class, which we've already used. The Java API is well documented, which makes it easy to find out what the various classes can do. The documentation can be viewed in a web browser. If you're not sure where to find it, just search for Java API. At first the documentation looks intimidating, but it's actually quite easy to use. In the upper left corner is a list of all the packages in the API. You might remember that we used the java.util package for the ArrayList class. On the lower left is a comprehensive list of every class in the API, so we could easily scroll down that to find string. On the right is a more detailed list of all the packages. The string class is in the java.lang package, so we can scroll down to locate that. Clicking on the link takes us to a page that lists all of the classes in the java.lang package. Notice that the two areas to the left are still there. Scrolling down we can locate the string class. And clicking on it takes us to the API page for the string class. Once again, this can look quite intimidating on first sight. However, one point to bear in mind is that the documentation for all classes in the API has a consistent look to it. That will make it a lot easier to find your way around as you explore the documentation for different classes. For this particular video note, we're going to be interested primarily in the methods of the string class, so we scroll down to the method summary section of this page. However, we won't explore it any further at this point, but we shall come back shortly once we've taken a brief look at the support system class. You can read about the project in detail in the book, but we simply want to draw your attention to the body of the main processing loop within the start method. This is where all of the interaction currently takes place. The customer's input is returned as a string from the getInput method of a reader object. The input is tested to see whether it starts with by, and depending upon the result, either the finished variable is set to true or a response is generated. Our goal for the program in this video note is to make the recognition of by a little less sensitive to exactly how it was typed, for instance by ignoring leading spaces and not worrying about capitalization. But first we note that the current test calls a starts with method on the input string. While we can probably guess what that does, it wouldn't hurt to check. For that we need to go back to the API page for string and find the description of starts with. documentation says, tests if this string starts with a specified prefix. That's fine, but we can get a little more detail by clicking on the method name. While this description doesn't tell us much more than we'd probably guessed, it does include the subtlety that passing an empty string to this method will always give a match. The main point here, though, is that the API documentation provides a brief summary for each method and also a more detailed description. For many methods, it will be essential to read the more detailed description for a full understanding of how to use them. Let's turn our attention now to our desire to be able to ignore leading and trailing space characters in the user's input. A more general name for space characters is whitespace. The name whitespace also tends to include tab characters, for instance. If we search within the page for the word whitespace, we find that we are led to a method called trim. The very first line of that description reveals that this method does exactly what we want, so let's use it in our program. Now we can test it. Now if we put a space in front of by, we should find that the program finishes. Something's wrong, that didn't work. What are we doing wrong? Nothing obvious from looking at the code. Maybe we should go back to the documentation to see if we can see what the reason is there. A closer reading reveals that this method actually returns the trimmed string. It doesn't remove the spaces from the string we called it on. In fact, this illustrates something that will be true of many of the methods of the string class. String objects are actually immutable, which means that you cannot mutate, in other words, change them. If we want to do something that would change a string object, the method actually has to return a new string object of the required form. Understanding that principle means that we can now correct our code. So here we need to actually assign the result of calling input.trim to the input variable. Now let's try that out. That seems to work fine now. We won't actually add the code to make the test ignore whether the string is an upper or lowercase, but as a clue you might like to search Strings API page for the phrase lowercase, either as 2 words or 1. We also covered this in the chapter. In summary, we've seen that Java library classes are well documented. The API documentation provides a detailed description of all of the classes in the Java API, which is large. The documentation is structured to make it easy to find classes, either by name or via their packages. A familiarity with key classes in the library is an essential part of programming, because effective use of library classes will save us a lot of effort.